This is Free Algebra Lesson 4-4, Simplifying Fractions. Equivalent fractions are fractions that describe the same part of a whole. For example, 3 over 4 is the same thing as saying 6 over 8, which is the same thing as saying 75 over 100. All three of those are the same equal fraction. They all describe the same part of a whole. Only one of those fractions, however, is in what we call simplest form. Simplest form is a fraction whose numerator and denominator have no common factors other than 1. So 75 over 100 would reduce to simplest form to be 3/4. To find equivalent fractions, you're going to just either take your numerator and denominator and multiply them by the same non-zero number, or you're going to divide them by the same non-zero number. For example, if I look at 18 over 21, first thing I come to mind when I look at that and say, oh, I need to find two equivalent fractions, is I'm going to reduce it to lowest terms first. I know 18 is divided by 3, and I know 21 is divided by 3, so I'm going to take and divide both of those by 3. 18 divided by 3 is 6, 21 divided by 3 is 7. So there's one equivalent fraction. It happens to be the simplest form of that. Then I can take 6 over 7, and I can multiply both the numerator and the denominator by 2. 6 times 2 is 12. 7 times 2 is 14. Or I could have taken my original problem, 18 over 21, multiplied each one of those by 2. 18 times 2 is 36. 21 times 2 is 42. All three of these are equivalent fractions. All you have to do is multiply both the numerator and the denominator by the same non-zero number, or divide the numerator and the denominator by the same non-zero number. 14 over 20. First thing I'm going to do, I'm going to reduce it. I know it's divisible by 2. So 14 divided by 2 is 7. 20 divided by 2 is 10. There it is in simplest form. Okay. So I'm going to take 7/10, and I'm not going to multiply by 2. I'm going to multiply it by 3. 7 times 3 is 21. 10 times 3 is 30. And that gives me an equivalent fraction to 14 over 20. So I now have two equivalent fractions right there. I could have done something as simple as saying, okay, I have 14 over 20. Let's multiply them by 10 and 10. Okay, 140 over 200. I'm going to multiply them both by 1,000. It doesn't matter as long as you multiply both the numerator and the denominator by the exact same factor. 10/12, I'm going to reduce it again. I like to reduce things. Reduce 9 by 2. That's going to make it 5/6. Then I'm going to take 5/6 and I'm going to multiply both of those by 3. So I'm going to get 15 over 18. I could have taken 10/12 and multiplied that by 2. And that would give me 20 over 24. All of these are equivalent fractions. And obviously, depending upon which number you multiply by, you may have a different equivalent fraction than someone else. All right. Remember the other day when we worked with greatest common factor? Greatest common factor has a very important use for us. It's helpful to simplify fractions. Because if you can divide by the greatest common factor, you can simplify fractions much faster than if you constantly have to divide out numbers. To simplify fractions, simply divide both the numerator and the denominator by the greatest common factor. And the easiest way to do that is to literally write out your problems in prime factorization. I'll tell you, it's the easiest thing to do. For example, here we have number 1, p divided by 2p. So this is p over 2 times p. The p's cancel out, don't they? This is the same thing as saying 1 over 1. Okay, this divides into 1, and this divides into 1. Doesn't go away. So the answer to this is on the top I have a 1, and on the bottom I have a 2. If I have 14, q to the second r s to the third, over 8 q r s to the second, 14 is 2 times 7 times q times r times s times s times s. 8, 2 times 2 times 2 is 8 times q times r times s times s. All I did was the prime factorization of both of those numbers. Now that I have the prime factorization of both of those numbers, I'm going to cancel out whatever they have in common. They have this 2 in common. I can cancel that out. They have a Q in common. I can cancel that out. They have an R in common. I can cancel that out. They have an S in common. I can cancel that out. They have a second S in common. I can also cancel that out. Once I've done that, what is left on the top? I'm left with a 7, a Q, and an S. So 7, Q, S. What is left on the bottom? A 2 and a 2. And 2 times 2 is 4. So there I have it. I factored out the greatest common factor, which was 2 Q R S to the second. Let's look at number 3. 24 times x times y. Well, 24. I might have to actually do that over here. 24, 2 times 12, 2 times 6, 2 times 3. So that's going to be 2 times 2 times 2 times 3 times x times y. And 8 is 2 times 2 times 2 times x times y. Again, I'm going to look at these and cross-cancel. Cancel out what I don't need. I'm going to use a highlighter this time. This 2 cancels with this 2. This 2 cancels with that 2. This 2 cancels with that 2. One of the x's cancels out, and one of the y's cancels out. What am I left with? On the top, I have a 3 and an x. So 3x. On the bottom, I have nothing. So I can either put it over 1 or I can just leave it as 3x. So there we have it. And everything, because obviously, the largest number that divides into 8 and 24 is 8. And the largest variable that divides into x squared is x, and the largest variable that divides out of y is y. Right? That is it for lesson 4-4.